Hi guys, so this is the third part of our application series, right? So my name is Garabo Sitole. If you're watching this video for the first time, please try and watch the previous videos. I have part 1 and part 2 of these videos, and it covers question 1 to 4 in depth on how you were supposed to do the questions. I must also acknowledge that the questions are not my own, but they belong to the School of Applied and Computational Maths, the University of Witwatersrand. So question 5 says a loan of 180,000 is granted at 15.6% per annum compounded monthly and is to be amortized by means of regular equal payments. So my I matches my N by equal monthly payments of 6,300 and a final payment, right, made 1 month after the last equal payment of 6,300. If the first payment is made 1 month after the loan is granted, then the final payment is equal to. So with all questions, as I said, you always solve the initial problem before anything else. So before we solve the initial problem, let us draw our timeline. So our timeline is going to start at T0 because the loan is always granted at T0. And it's going to go all the way to, we don't know for now. That is what we are going to solve for, our N, right? So at T0, the loan is granted and it is 180,000. My I-12 is 15.6% over 12 per month. And my PT is made 1 month after the granting of the loan, and it is 6,300. T2, 6,300, etc. So I'm going to use the initial problem. Going to solve the initial problem using my CMPD function. So CMPD, my PV is negative 180,000. My PT is 6,300. My I is 15.6 over 12. My N is what I'm solving for. So my N is actually equal to, put this in my calculator, N is what I'm solving for. My I is 15.6 divided by 12. My PV is negative 180,000. My PMT is 6,300. So solve for your N. You find that your N is 35.94. 35.9474, etc. So remember that when you get your N to be a decimal, you have final payment. So the payments will end at the whole number T35, and my final payment will be made at T36, right? So this is where they will end, and my F will be at T36. So to calculate my F, what I need to do is to calculate the balance outstanding at a period before my F, and that is at T35, and then compound whatever answer I get to T36, right? So to do that, so sorry. Okay, I'll just give you a moment to like catch up because I didn't see that my page was cut. So I hope you guys are done catching up. So let's solve for F. So remember that since our information is already on the calculator, all we have to do is to press the amortization button, right? So I'm going to use the amortization button to solve for my F. And at PM, so press amortization. At PM1, press 35. PM2, press 35, right? There goes your information. And so for the balance outstanding at T35, right, and you get that the amount is 5,893. So PM1, press 35. PM2, press 35. Your whole information will be there. Balance outstanding, solve, and it is equal to 5,894,4483. So now that you have this amount, just make sure it's positive. If it's not, you multiply it by -1. And then all you have to do is to compound this amount with interest all the way to T36. So whatever amount F is actually equal to, F is equal to 5,894,448 compounded with interest to F to T36. So 1 plus whatever my interest rate was, 15.6% over 12 to the power of 1 compounded with 1 period, because from T35 all the way to T36 is 1 month. So to solve this on my calculator, I put answer 1 plus 15.6% divided by 12, right? And then I get that. There we go. Okay, let's just get our balance outstanding and store it so that when we make a mistake, we don't have to do everything else. Okay, so the answer times -1. Okay. Plus 15.6% divided by 12. You get 5,971.08 as your F. 5,971.08 as your F. Our next question says a loan of 40,000 is to be amortized by 60 regular monthly payments. So a loan of 40,000 is to be amortized by 60 regular equal payments. Okay, at an interest rate of 16.5% per annum effective. The repayments start one after the granting of the loan. If the annual effective rate increases by 1% per annum, so if the interest rate increases 1% per annum immediately after the 36th payment, then the new equal monthly payments to the nearest cent that will amortize the loan in the same period are equal to. So what we have to calculate is the initial period first of all, but let's draw a timeline before doing anything else. So we will draw a timeline, right? And then solve the initial problem. So the a loan is always granted at T0 and the value of the loan is 40,000. They tell us that the repayments start one month after the granting of the loan. So they start at T1 PT, right? So we are told that the initial interest rate is 16.5% per annum. So that tells me that I have to solve for my I-12, right? Because my payments are made monthly. So I have 16.5% over 12 to the power of 12 is equal to, 16.5% to the power of 1, because it is an annual interest rate, is equal to 1 plus I-12 to the power of 12. So my I-12 is equal to 1 plus 16.5% to the power of 1 divided by 12 minus 1 times 100. Okay, and I get 1,28080. And I will solve this, I'll store this under A, right? Okay, so let's continue. So my I-12 is A%, right? So let us solve the initial problem using the CMPD button on our calculator. So initial problem, and we use the CMPD function on our calculator. So N is what we are solving for. I is A, what we just solved here. My PV is 40,000. My PT okay, I see my mistake. So we have N. We are told that the loan of 40,000 is amortized by 60 equal monthly payments, and I'm like, we are solving for N. Sorry for the confusion. So my N is 60 and I'm solving for PT because I was wondering how we have both N and PT to be solved. But anyways, it was just a silly mistake. So we are actually solving for PT. Our payments are ending at T60. T60. Right? So let us just put that in our calculator as dries 60. My PV is negative 40,000. PT is what we are solving for. Solve. You get that PT is 959,377, etc. We will store this under B. Answer, shift store under B. Right, so it is stored under B. My N is 60. Okay, so we've solved the initial problem and it is under our CMPD, right? So let's just go back to look at what they're asking for. They said that if the annual interest rate changes by 1%, increases by 1% immediately after the 36th payment is made. So at T36, let's just scroll up a bit. So at T36, we are told that the interest rate increases by 1%. Just want to move my T36 to the side so that I'm able to draw my new timeline. So at T36, we have an interest rate change, and remember, it is the interest change was made after the payment, right? Meaning that T36 won't be affected by the interest rate change. From T37 all the way to T60, only those payments will be affected by the interest rate change. So T36, that's where the change happened, all the way to T60. Remember, they said in the same period, so I can only end at T60. So for this new loan, the new payments will start at T37, right? That is when we'll have our T1 with the new increase, with the new increased rates. So make this T35. Okay, so at T36, that's where it changed. Our first payment is made at T37. Period before T37, that is where our present value is for the new timeline, and that is at T36. So to find out what the present value is, I need to calculate the balance outstanding of the loan at T36, right? And that will be equal to my PV for the new timeline. And then I have to calculate my PT star, right? So let us do just that. I'm going to continue in another page. Just make sure that you guys don't get confused by everything that is happening. Sorry. Keep forgetting to bring it up. But anyways, yeah. Okay, so the balance outstanding at T36. Remember, we already have everything under our CMPD. So you just press amortization, you press 36, 36. You go down and you solve for balance outstanding. You find that your balance outstanding is 19714. 19174,92661, right? So this balance outstanding is actually going to be my present value here, right? So remember that they said that the interest rate increased by 1% per annum. So I need to add 1% here and then use the equivalence formula to convert it into a monthly interest rate. So let us solve for I12 star. So I'm saying that they said that the 16.5% has increased by 1%, right? So we have 17.5% per annum as the new interest rate. I need to now use this interest rate that I have to find its equivalent formula, its equivalent I12, right? Because the payments are still being made monthly. If the payments were changed to be made quarterly, then I would use whatever interest rate I have to change it into a quarterly interest rate. using the equivalence formula, right? So yeah, 1 divided by 12 minus 1 times 100, and I get 1 plus 17.5% to the power of 1 divided by 12 minus 1 times 100. I get 1,352972%, and I will solve this under, I'll put this under C. Shift store C. Okay, cool. So now I have my balance outstanding, which is the new present value. I have my I. So I just don't want things to get messed up, but I'll just put the balance outstanding right here. So we said that the balance outstanding is 19174.92. My new I12 plus, star, is equal to 1,3529. Okay, so let us also find our new period, right? The timeline. So it is starting at T36 and it is ending at T60. So I just need to say where it is ending minus where the present value is, and that is at T36. So it is ending at T24. The new timeline is ending at T24. So they said original time period, hence the first thing I had to do was to put T60 on my timeline. Now there's an interest rate change, but they will make new payments to amortize the loan in the same payment, in the same period. So I do not have to calculate a new period. All I have to do is to calculate for the new PT, what is my N? To calculate my N, I need to take where it is ending. It is ending at T60, subtracting where the PV is. In this case, the PV is actually at T36, right? So yeah. So now I have everything I need. Press my compound function. My N is 24. Just explained how we got that, right? And my I is stored under C. Remember here, that is where we stored our I, under C, right? So our I is under C. Our present value is the balance outstanding, remember? And we solved for the balance outstanding and we stored it. Did we store it? Oh, don't tell me we didn't store it. But anyways, here's the balance outstanding. It is 19. Oh, you can just press shift catalog, I think. Let's see if we have the balance outstanding. Oh, we don't. Okay. Either way. So was saying press 24. Okay, wait. My present value is the balance outstanding. Just needs to remove everything else. Balance outstanding, and we are saying that the value is 19174.92661, right? And I'm looking for my PT. So I solve for PT and I find that this is not the answer that I got initially. Let me see where I went wrong. Okay, guys. Yeah. So we have N as 24. We have our I as 1,35. That is the new I, right? So we are solving for the new payments. I have my N as 24. My I is this interest rate that I solved for right here, right? So here it is. So N is 24, that interest rate. Remember, the balance outstanding needs to become your new PV. So there it is. Then you solve for 967. I think my mistake was not canceling FV, right? So when you solve for it, you get that the new payments are 967.53. So let's just write that down. So the new payments, so use CMPD, where your N is 24, your I is the C. Don't forget to change the C. Your PV is the balance outstanding at T36. In this case, it is 19174.92. Right, PT solve. So the PT is 967,53. So yeah guys, I guess that brings us to the end of this particular video. I will continue with the rest of the questions in another video. Thank you for watching.